Okay, the purpose of this video is to help you start to make a diagram about the view from space. We spent a lot of time collecting data about the length of day, right, and the height of the sun. That was our view from Earth. And then we used the gizmos to see what's happening in space. So I'm going to review that a little bit, talk about that. At the end of this, in your notebook, you're going to do a rough draft of what you think is happening up here. You're going to make sure to include these words: rotation, revolution, axis, Earth, Sun, and North, or N. Okay? That's the goal. So, let's review. Rotation causes day and night. We know this. When the Earth is facing the sun, it's day. When it's facing away from the sun, it's night. How can we show that? We can show it like an arrow, but even this one is hard. It's a little 3D. You might have to draw it like this around the Earth, right? You might be able to get an arrow that looks like that, right? But you're going to show rotation, right? You're going to be drawing, so you're not going to get a cool GIF like that, right? But you're going to show that the Earth is rotating to cause day and night. Why? Because we're talking about what's happening in space to cause the length of day and night to change. So we have to start with the basics. First, what causes day and night? Rotation of the Earth, right? How does revolving around the Earth cause different amounts of day and night? So here are some other images that kind of show you when the Earth is revolving, it has the different amounts of light lit up. When it's day, you can see this part is day here, but this part and this part is day, and this part has a lot more day to it, right? Why is that? We have learned about that, right? That's what we've just been doing gizmos with. But that's what you want to explain. Yes, it's revolving around the Earth, but what else is causing different amounts of day and night? Okay, you can see it in this GIF, how some places there's a lot more light on one part of the Earth than in others. The Earth is rotating on its axis, it's revolving around the sun. As the Earth rotates, it also revolves around the sun. What does this revolution cause? You should be thinking about the tilt of the axis, right? Because that's what the gizmos was all about. This X, say that's about 44 degrees. That's about where latitude, where we are, right? As the Earth moves around the sun, the axis, so this is the North Pole. So I've labeled north. You would label north too in your diagrams. Always points the same direction. It's not going to flip-flop back and forth. See, the north is always kind of pointing this direction. But how much the X is getting lit up by the sun, well, that changes as it goes around. So you want to start to think which seasons are which. Okay? Again, in this diagram where it's tilted, it's that tilt that causes the different amounts of light. If it wasn't tilted, even if it went around the Earth, even if it revolved around the sun, without that tilt, you'd get the same amount of light like we saw in our investigation. Which of the positions do you think is summer in the northeast, where the X is? Which one of these do you think is summer? Okay, you're going to create a model. First, you're going to do it in your notebook. And then you're going to share it with a partner. So if you're watching this video with a partner, I want you to both stop and write it in your notebook. You're going to write diagram draft in your notebook. The practice slides will show you how to do that. Okay, I want you to write what you think. How you would show what's happening from space to cause the different amounts of light to change on Earth using these words. You do yours, your partner or partners do theirs, then you come back together. Then you're going to go on a whiteboard. Okay? You and your partners may try this first one and then look at each other and go, that doesn't make much sense. Or it's too hard. Can't really figure it out. There are two things you can do. You can go back to gizmos and actually watch this viewpoint. This one down here especially might be particularly helpful. Okay. I'm just going to do this real quick. If you watch this down here, you can see the amount of light here. But if you just let it play and play, I've got it on pretty high simulation speed. Right? You can watch it, and I can speed it up. Because I want to watch it travel a whole year, right? We're not slowing it down this time. Right? It's moving pretty quickly. No, it's not, right? I lied. It's not very quickly. Turn the sim speed up. Okay. Now you're watching it. Right? What's happening? And we're at the end of the year. But what's happening? Right? I can redo it. So watch that. To give an idea of what you're in a diagram. Another option that you can do is I have a video in the practice, a link. It's not an Edpuzzle, of just a model. So it shows you how to do the model. You can watch the video and see if you can do a model from there, or you can come and see me and I'll help you set up this model in the classroom. All of this to try to get you to create your own diagram of what's happening in space. Then compare it with your partners, and then as you can, go to the boards. Okay? Good luck. Have fun.